Good morning, everyone, and good evening, everyone. Thank you for joining today's new product update webinar. Today, we'll be talking about decreasing your factory downtime with TPS 274C65 and its advanced load diagnostics. My name is Paul Cumiller, and I am a product marketing engineer at Texas Instruments. Before we get started, I would encourage you to ask questions throughout the presentation using the Q&A box, where we have Ichi Zhang, the systems engineer for this device, standing by to answer any questions. We'll also be conducting a Q&A at the end of the presentation. All right, so today we're going to go ahead and get started on our topic. So before I start on the presentation, just wanted to go over the agenda that we have today. First, we'll start with the power switch overview. Then we'll talk about high side switches in particular. And then we'll talk about the device of interest today, the TPS 274C65. So we'll talk about some of its many features that it has. Additionally, we'll talk about some of the industrial applications where this device could be used. And then we'll talk a little bit about the EVM that we have for the device. So starting at the power switches level, I just wanted to give an overview of what power switches is to TI. So power switches is anything that switches DC power from input to output. So if you have a 24 volt input and you want to switch 24 volts to the output, you can use a power switch to do that. Our devices generally only handle DC levels, but they can also handle levels up to 2 kilohertz. Within power switches, we have 3 different buckets. We have input power protection, power distribution, and output power protection. So within input power protection, we have ideal diode controllers, hot swap controllers, and eFuse devices. In power muxes, we have 2 input, 1 output power muxes, which can be used to prioritize supplies. We have load switches, which can be used to provide processor power sequencing, as well as module turn on and turn off. And last but not least, we have high side switches, which are used to distribute power off board. So today we'll talk mostly about high side switches. So going into some more details on TI's high side switch portfolio. These are really integrated power switches, which are used to drive off-board resistive, inductive, and capacitive loads. And they're generally used at the output of the system. The main reason why they're used at the output of the system is they have an integrated VDS clamp, which helps to clamp the voltage at the output if there's ever an inductive kickback. So what the device does is it helps to clamp the negative voltage, it turns on our MOSFET, and then dissipates the inductive energy through the MOSFET. Really what makes our devices stand out against our competition is the adjustable current limit. Many of our devices offer an adjustable current limit, either through a pin with an external resistor or through serial protocol interface or SPI. The other differentiating feature is the IMON output. So our device can sense how much current is flowing through the MOSFET, and then this could be sent to an ADC to do some data processing. Really quickly, just going over some of the power distribution use cases of where a high side switch could be used. Generally, it's used, as mentioned, at the output of a system. So if there's ever multiple modules that you might have and there's a short in one of the cables, a high side switch can be used to help turn off just power to just that module and still allow the rest of the system to operate. So really it provides the ability to isolate in the case of a failure somewhere in the system. So the switch will open once it hits thermal shutdown, and we'll stop current limiting and hit thermal shutdown. Additionally, it can also do wire break detection. So the device, high side switches, can use its current monitoring to detect when there's a wire break and then alert the system that a wire break has occurred. It can also be used to drive inductive relays, these off-board loads through long cables. So our device can help to control the inductive kickback when driving inductive relays. And last but not least, it can also provide inrush current control. So if there's large capacitors, say for an HMI, the device can help to control the inrush as you start up that system. So now going into the TPS-274C65. So this is our first device with SPI for our industrial high-side switch family, and it's a quad channel device. And each channel can support up to 1.65 amps of current. The operating range for this device is 10 volts, from 10 volts up to 36 volts, with up to 48 volt transient support. And I'll go a little bit more into these features in the next slide. But the other key thing that I wanted to highlight here is the package. So this device will be available in a QFN 6mm by 6mm package with 0.5 millimeter pitch. So going over the TPS-274C65 and some of its unique features. The first one is the low RDS(on). It has 65 milliohms of RDS(on) per channel. So really what that can help you to do is lower your power dissipation. Additionally, this device has the flexibility to allow you to parallel channels for a lower RDS(on) and higher output current. Next, it has a SPI interface. So the device can either be configured in a daisy chain mode or an addressable SPI with or without CRC. And really the benefit of a SPI is it allows you to reduce the cost of using many optocouplers to isolate all the different signals. So with just one SPI bus, you can provide communication to multiple TPS-274C65s. Additionally, this device has an integrated ADC. So this is one of the first in the industry for industrial high-side switches to have an ADC. So what that really allows you to do is convert the current sense information, temperature sense information, the V out sensing, and the V in sensing, and allows you to convert that to digital and then transfer that over SPI back to the MCU. And something else this device has is optional gate drivers to drive reverse current blocking FETs. So this really enables you to use this device in universal input-output modules, where this channel could be either configured as an input or an output. And last but not least, it also has a LED switch matrix for driving status LEDs and fault LEDs. So we'll get a little bit more into detail on some of these features. So starting with the serial protocol interface, or SPI, TPS-274C65AS and then the BS versions have SPI communication. So really the benefit again of SPI is it allows you to reduce the amount of GPIOs needed. So you can see here through optocouplers, you might need a lot of optocouplers to interface with a parallel type of high-side switch. So really with a SPI communication, you can reduce just down to 4 pins through a SPI bus. So data in, data out, clock, and then chip select. In terms of the SPI configurations that our device has, you can either do addressable SPI, and so each different device you want to address to will have a different address configuration that's set through an external resistor, and this allows you to communicate to multiple different devices. So by writing the address of the device you want to communicate to, you can communicate to one of the TPS-274C65s. You can also configure it in daisy chain mode. This allows you to, in one SPI frame, update any of the different devices that are daisy chained together. We have both, we have 3 different options in terms of SPI frames. There's 16-bit, 24-bit, and 32-bit. And we have options with and without CRC. So CRC is really used to ensure the data communication integrity. One of the other cool features this device has is in each SPI frame, you can actually simultaneously update the switch state. So you can also read from a register as well as write to a register and simultaneously update the switch state. So instead of needing 2 SPI writes or SPI reads to do this, you can do it in just one. So now quickly going over the integrated ADC. So this device, the TPS-27-4C65 integrates current sensing, temperature sensing, and V-out sensing for each channel. And with the integrated ADC, you can convert these analog signals into digital and then transfer them over SPI. So it really provides a unique value prop of this device, and it really allows you to reduce the system cost by not needing an additional ADC. It removes extra routing for the ADC channels, and it also enables this signal to pass over isolation barriers. The current sensing can be used to sense how much current is flowing through each of the internal MOSFETs. It can also be used for temperature sensing of those MOSFETs to see how cool or hot the device is, as well as VS sensing, so you can sense the input of the TPS-27-4C65. So the refresh rate of the integrated ADC is 65 microseconds. The ADC function can be deactivated altogether through SPI if you don't want to use it. And any of the ADC measurements can be deactivated. So it provides that flexibility. In terms of the ADC scheduling, it's in a round robin fashion. So with the following order. So current sense, temperature sense, V-out sense, and then V-in sense. So now just to look at what the ADC is capable of, this is on the left here is a example of a solenoid actuator, and this is the startup current of the solenoid actuator. So some of these notches are the actuator, the plunger actually moving in the actuator. So with our integrated ADC, you can actually capture these unique things that you see with an actuator. So really what that helps you to do is provide predictive maintenance, or it provides some diagnostics back to the system. So instead in the past where you would turn on the high side switch and maybe you don't know if you've actually turned on the load correctly or not, this provides you that feedback that says, yes, the high side switch is on and it is drawing 500 milliamps or whatever it may be. In terms of increased power density, really the TPS-27-4C65 can really enable lower power dissipation or increased power density because of its integrated 65 milliohm RDS(on) MOSFETs. Additionally, it provides the optional low voltage supply, which allows you to use an external buck converter to increase the system efficiency of the device. So when you compare this to other competitive solutions in the market, the TPS-27-4C65 can reduce the power dissipation by 40% for a 16-channel 500 milliamp digital output module. So really what this reduced power dissipation can really help you to do is either provide higher power modules or smaller module sizes as the amount of heat has been reduced. And below just shows a comparison between some of the competitive solutions out there in the market. So when you take a look at the power dissipation, it's about 40% less. As mentioned, there's optional reverse current blocking drivers. So what this really allows you to do is this device to be used in a universal input-output module. So if you want to configure this channel as a output, you can enable the reverse current blocking FET to provide a low RDS(on) path to the output. And if you ever want to configure it as an input, you can disable or deactivate this reverse current blocking FET and allow the current to flow to the digital input circuitry. So when you pair the TPS-27-4C65 with maybe an ISO 1228 from TI, you can create a universal digital output, input-output with these two devices. And then now going over to talk a little bit about the LED matrix. So the TPS-27-4C65 AS version has an integrated switch matrix. So with just 4 pins, the device can switch up to 8 different LEDs. So how it's done is each of them have an independent clock signal with an on phase offset from each other. So this enables you to just, with just 4 pins, we can drive up to 8 LEDs. So the LEDs can drive up to 1 kilohertz in terms of its PWM frequency. And you can create any color from green, red, and yellow through the LED driver. In terms of the LED driving decision, this is controlled through SPI. So the TPS-274C65 doesn't make any decisions based on the switch state. So this is all controlled through a register, which can be controlled by the user. Cool. So now to talk a little bit about some of the industrial use cases that we have for the TPS-274C65. So first, starting in factory automation, these high-set switches are often used to distribute power, and that's either through a digital output function or in larger systems, such as robotics, linear transport systems, and CNC machines. So there's a lot of different applications where you need to provide a 24-volt control power to the rest of the system. Another application where you need to distribute power, control power, is with building automation. So for things such as fire alarm control panels, building security systems, HVAC controllers, you need to have the ability to provide some of this power from the control panel that you have to the rest of the building. So with the high-side switch, you can provide both that power distribution as well as power protection if there ever was a short circuit anywhere in the building. And then in terms of grid infrastructure, these high-side switches are also used to distribute power in EV chargers, string inverters, and energy storage systems. So these can be used to also provide power distribution and provide short circuit protection. So focusing in on factory automation and PLC modules, this is one of the main applications this device was designed for. So it has a lot of different hooks and features to make it the most optimized solution for digital output modules. So with the integrated ADC, the SPI capability, the LED switch matrix, and the reverse current blocking FET, this really enables the device to be an optimized solution for digital output modules. Additionally, one of the other benefits of this device in a digital output module is the low RDS(on). So one of the things, a lot of times these PLC modules are in a cabinet and maybe they have not a lot of area or places for the heat to dissipate or to be removed from the system. So by keeping the heat dissipation low with the TPS-4C65, because of its low RDS(on), you can reduce, you can enable smaller sizes or higher power density for these modules. Additionally, within factory automation, also for remote IOs or IO links, IO link controllers, the TPS-274C65 is a really good fit. With its reverse current blocking FET, it can be used for some of the input-output signals that are there, as well as for the CQ line or for the sensor power supply on IO link. Now going over to factory automation, and this is specifically for power distribution in large machines. So in large machines such as robots, CNC machines, linear transport systems, a lot of these larger machines where you need to distribute power from maybe one AC supply and provide, convert that from AC down to DC and then provide that controlled power throughout the system. You can use the TPS-274C65 to provide that power distribution. So if you need to provide power to different sensors, maybe some small servo drives, or maybe to machine vision, holding brakes, fan power, whatever it is, high-side switch can be used to provide this protection. So it can provide localized protection. If one sensor is bad, it doesn't cause the whole system to come down, and it'll only turn off that one sensor. So it can really be used to help safely provide 24 volts to the rest of the system. One other thing is the device can also provide predictive maintenance. With its integrated ADC, it can allow you to remote into the system and then see if there's anything that's wrong in the system. So if for some reason this machine went offline, you can use the diagnostics to figure out if there's anything that's going wrong in the power distribution to really help you find the root cause quicker and get your system back online faster. Now going over to building automation, the power distribution. So for things like fire alarm control panels, building security systems, and HVAC controllers, there's usually these loop outputs that exist in the control modules or control panels. So you need to provide power out to the loops to power the different things that are attached to the loop. So the TPS-274C65 can provide those features. They can provide short circuit protection, maybe if there's a bad sensor or a bad detector, that can provide the short circuit protection to protect and just shut off that one loop. It can also provide some fault diagnostics to allow for quicker debug and get the system back on. And then going over to grid infrastructure. So taking a look at power distribution within grid infrastructure. So for EV chargers or for energy storage systems or string inverters, like all the other systems, you need to provide power distribution. So for EV chargers, for example, maybe there's an LED module you need to provide 24 volts to provide power to the LEDs. Or maybe there's a charge control module or a power module, which has a 24 volt control input. So from this main, either high voltage DC or high voltage AC, you'll convert down to a 24 volt DC, and then you can provide power distribution of the control voltages to these different modules. Another example is the HMI module, where you may need to, which is used for payment. So providing power to that system is also important. Some other examples are providing power to the coil of the relay disconnect, maybe for the EV charger for the port 1, and also for port 2. And then now going over to energy storage systems. So maybe these are installed in a building, or maybe they're installed somewhere remote in the connected to a wind farm or a solar farm. So one of the big things that is needed is really robust protection to make sure these things are safe, and they have a lot of diagnostics so that if they ever do need to be maintenance, they know quickly what to maintenance and get it back online. Because one of the goals of energy storage systems is to always have the power available. So having a lot of diagnostics and protection is important in some of these equipments. So if you're interested in getting started with this device, we have a EVM online, the TPS-274C65 USB EVM. So this really enables an out-of-the-box experience. So with just one USB connection and a small GUI download, you can start evaluating the TPS-274C65 in less than 5 minutes. So that the EVM offers 2 TPS-274C65s, a buck converter, which allows you to provide the low voltage power supply for the 274C65, as well as an isolation barrier and a microcontroller to allow you to interface with the GUI and also control the TPS-274C65 over SPI. So this is available in addressable SPI configuration, and the device, or the EVM, has a very nice GUI that goes along with it. So it has a what we call a command center, which allows you to look at all the different faults, statuses that our device can detect. So there's a lot of different things the device can detect, and you can kind of use this GUI as a command center to understand how the device is operating. So you can find this device on the product folder, the TPS-274C65 product folder on TI.com. So with that, just wanted to go over a really quick summary of the TPS-274C65. So really the main points are reduced power dissipation, real-time diagnostics, high configurability and integration, and reduced system cost. So this device really provides one, the reduced power dissipation through the low RDS(on), real-time diagnostics with the integrated ADC, high configurability through the SPI interface, and the reduced system cost. With all the integration of the different things it can do, it can help to reduce the system cost. So with that, just wanted to part one last thing is there'll be 3 different variants: in AS variant, which will have all the features integrated, and then we'll have a BS version, which has just the SPI interface, and then we'll have a CP version, which just has a GPIO interface. So all these devices will be available for production on TI.com by mid-September. The AS version is currently sampling on TI.com. So with that, I wanted to open up for questions and see if anybody had any questions. Cool, I think I see some here. Cool, so one of the questions is, what about the internal inductive load freewheeling diode specification? Is it suitable for automotive grade? So this device is not automotive qualified. In terms of the integrated VDS clamp, the minimum voltage it breaks down at is 39 volts. But right now, there's no plans to automotive qualify this device. In terms of energy dissipation, so this is something that, or there's a question on, can you talk about the energy limitation as die size is so small? So these devices are, in each of our different data sheets, we talk about how much energy these devices can dissipate. So when we release the device on TI.com, the final version, it'll have more information about how much energy our devices can dissipate. But we try to maximize that as much as possible. It looks like we have another one. Are the reverse current blocking drivers designed to drive PMOS or NMOS FETs? So they're designed to drive NMOS FETs. So they provide a charge pump or a 5-volt supply to drive the NMOS FETs. What's the max SPI communication speed? So the max SPI communication speed is up to 10 megahertz. Let's see here. I think we got a couple more here. What's the, is the LED module controlled by the device, or do we have the flexibility to control the LED through SPI? So good question. So the flexibility of this device, that it really allows you to control the LEDs through SPI. So the device itself does not control, does not automatically update based on the switch state. So it's all controlled by the user. If I have a 16, I got another question. If I have a 16-channel output module, can I daisy chain the ICs and use only one isolator for the communication? So the answer is yes. So with just one digital isolator chip, like an ISO 774, you can daisy chain multiple of our devices together to communicate to all of them. Are there evaluation boards available? Is the firmware ready with the boards for easy testing? So there are EVMs available. So if you go to TPS 274C65, you type that into TI.com, there'll be a link at the bottom for a link to the different EVMs we have for this. And we have firmware ready for the boards for easy testing. When will the device be launched to the market? So the device is currently sampling on TI.com, and then the production launch of it will be mid-September. Then last but not least, will the slides be available for download? So yes, the slides will be available for download. So if you go to ti.com/NPU, you can find the slides. One last question is -55 degree temperature. Can it work for this device? So right now the device is only capable of -40 degrees C. Cool. With that, I think that's all the questions we have time. We're about out of time, but appreciate it, everybody, for your attendance, and let us know if there's any questions in the future. Thank you for your time.